Today we're going to be looking at another differentiation rule, which is called the product rule. So think about in math, product in math means multiplication. So this is a rule for multiplication. Before we jump straight into the rule, I want to look at an example that we've seen in the past. So let's say that I am given y is equal to 3x minus 2x squared being multiplied by 5 plus 4x. Well, if we do not know the product rule yet, then the only way I can differentiate this to find y prime would be to actually FOIL it out first, distribute it out, and then use the power rule. So I'm going to do that. I'm going to go ahead and distribute and simplify. So multiplying it together, I have 15x plus 12x squared minus 10x squared minus 8x cubed. Of course, I can combine like terms here. So y then would equal 15x plus 2x squared minus 8x cubed. Now it's all in terms of single terms, which allows me to differentiate to find y prime. So using the power rule, this would go to 15 plus 4x minus 24x squared. And that is my derivative. Now you might ask, why would we need a rule if I can always FOIL and then use the power rule after that? And we'll actually discuss that momentarily. Let me first show you what the product rule actually does. So with the product rule, I am taking the derivative of two functions being multiplied together. So I'm going to write that as f of x times g of x. And the formula says you take the first function, which would be f of x in this case, multiply it by the derivative of the second function, so that would be g prime of x, plus the second function, so g of x, times the derivative of the first, which would be f prime of x. So again, product rule says take the first, multiply by the derivative of the second, plus the second, times the derivative of the first. Now, keep in mind you are adding in between, and so if you switch this half with this half, and do this half first, it won't matter and it won't make a difference mathematically because you're just adding in between. So let's do the same example we just did a moment ago, but now using the product rule. So going back to our previous example said y was equal to 3x minus 2x squared times 5 plus 4x. But rather than FOILing then using the power rule, I'm going to jump straight into the product rule. So product rule says y prime would equal the first. So I'm going to go ahead and label this here. This would be like my f of x. And then this would be like my g of x. So product rule says I take the first, which in this case is 3x minus 2x squared, multiply it by the derivative of the second, so multiplying by the derivative of 5 plus 4x, which goes to 4. I'm going to add that to the second function, which is 5 plus 4x, times the derivative of the first, and the derivative of 3x minus 2x squared goes to 3 minus 4x. So if I label it out, this is your f times the derivative of g, so g prime, plus g times the derivative of f, so f prime. Or in words, the first times the derivative of the second function plus the second function times the derivative of the first. Now, if I go through and actually simplify this thing, I will still have to distribute and still FOIL here. So now I'm given 12x minus 8x squared plus 15 minus 20x plus 12x minus 16x squared. If I combine like terms, that'll give me 15 plus 4x minus 24x squared, which is what we got in the first example when we first FOILed it and then used the power rule. So you might ask, what's the point? Why would we do this? If I was just trying to find the derivative and the problem did not require me to simplify, I could actually leave my answer right here if I wasn't told I had to keep simplifying, which would save me a lot of algebra. If I have to simplify and get it down to single terms with nothing being multiplied anymore, of course that does not save us any algebraic steps. I still have to distribute, I still have to multiply here, combine like terms, but there will be functions that we see, and we'll see this in the next example, where the only way to find the derivative would be to use the product rule, because I don't have the option of actually foiling first like I do in this case. So let me show you what I mean. So let's say that I am given y is equal to 3x squared times sine of x. Well, in this case, I do not have an option to simplify first. There's no way I can actually multiply this and make this any simpler than it already is. So no matter how I look at it, I'm always going to have two functions of x being multiplied together. The 3x squared is always going to be multiplied by the sine of x. So if I was thinking through it like product rule, this would be my f, that would be my g, and so now I have to do product rule based on the way it's laid out. So in this case, y prime would equal the first, which is 3x squared, times the derivative of the second function, the derivative of sine is cosine, plus the second, which is sine of x, times the derivative of the first, which will be 6x. So in terms of the labels I have above, this is your f, this is your g prime, that's my g, and that's my f prime. And the only thing you could do to rewrite it is I could move this 6x in front of the sine x just to make it look a little bit cleaner. But at this point I have found y prime, which is what the problem was asking me to do, was just find y prime. So let's look at another one. Let's say that I am given y is equal to x to the sixth times cosine x. So I have two functions of x being multiplied together. I have x to the sixth being multiplied by cosine x. So definitely going to be a product rule here. So product rule says I take the first, which is x to the sixth, times the derivative of the second. Well, the derivative of cosine is negative sine, so I can put the negative in front, and then sine of x, plus the second, which is cosine x, times the derivative of the first, which is just a little bit of power rule there, 6x to the fifth, and there's my derivative. So here's another one. F of x is given as root x plus 3x squared being multiplied by 4x to the fifth minus 2. Technically, I can FOIL that and then use power rule. However, I see the square root, and I don't really feel like multiplying and distributing with the square root of x, even though I can. So I'm going to apply the product rule. So I have one function being multiplied by another function. So f prime of x equals the first, so I'm keeping everything from that first half exactly the same, times the derivative of the second. Well, the derivative of 4x to the fifth minus 2 is 20x to the fourth, plus the second, 4x to the fifth minus 2, times the derivative of the first. Now with the derivative of the first, I have to remember how to rewrite the square root of x. That is the same thing as x to the 1/2. And so after I rewrite it, I can apply the power rule, 1/2 x to the negative 1/2, and then plus 6x. So last example, this one's going to change it up just a slight bit. The instructions here say find f prime of 0 for the following function. F of x is equal to 3x to the fourth minus 2 times 4x squared plus 10x plus 5. So applying the product rule, I have a first function times a second function. So f prime of x would equal the first, which is 3x to the fourth minus 2, times the derivative of the second, which is 8x plus 10, plus the second, so 4x squared plus 10x plus 5, times the derivative of the first. Well, the derivative of 3x to the fourth minus 2 goes to 12x cubed. Now, keep in mind, if I actually want to find the derivative at a point, I just found the derivative. I just found f prime of x. So there's no need to simplify this before I plug in 0. I can go ahead and just plug in 0 at this point. So f prime of 0 would give me 0 minus 2 is negative 2, times 0 plus 10 is 10, plus 0 plus 0 plus 5, times, and then if I plug in 0 for the last x, that goes to 0, so this whole term is actually going to cancel out and go to 0. So f prime of 0 in this case will equal negative 20. So thank you very much for watching. If you enjoyed it, please subscribe by clicking the link below.